Welcome back. We got the information we need, and again, our directions say identify the center and the radius, then graph. So I've done that. The center is -2, 1, and the radius is 5. Now we could have gotten that just typing that into Desmos. Hopefully I haven't made any mistakes and you get the same answer as me. -2, 1, radius 5. So you can do this problem either way. You can go to Desmos and notice this and graph it, or not using Desmos, you can do the algebra, find the center and the radius, then graph it. Two ways to do this problem. Okay, next one. Oh, this is kind of interesting. I think it's pretty close to the way I need it to look. Let me just copy the problem down on a piece of paper. Okay, so right now, I don't really like the way it looks. I wish that everything was all the way over to the left. So I'm gonna add x squared to both sides, and I'm gonna add y squared to both sides. Okay, and so now this side has 0 plus 0, which is 0. This side has x squared plus y squared minus 9. And so I'm noticing that I have a square and I have a square. So I don't have to complete the square. I already got a square. This is a square, x times x. This is also a square I could think of as x minus 0 squared, and this is y minus 0 squared. And so the only problem I have is I need my radius. And so that can be written as that, and that can be written as that. But I do want to add 9 to both sides so I can find my radius. Now that it looks like this, using the same relationships we did before, our center would be at 0, 0, and our radius is not that number. Our radius squared is that number. So the square root of that number would be 3. And that's the information I need. So on question 6, I have the center is at 0, 0, and my radius is at 3. Let's go ahead and graph it. Awesome. All right, once again, you could type all that into Desmos, figure out where the center and the radius is, and graph it. I'm gonna try to use the algebra. Because ultimately on the EOC, there is no Desmos. So, working through the problem the old-fashioned way, we see I need to get everything on one side. It's gonna leave me 0 on that side. So I'm gonna add x squared to both sides, and add 6x to both sides, and add y squared to both sides, and subtract 2y from both sides. Okay, so I have a whole lot of nothing on this side now. And I have a whole bunch of stuff here. This and this and this and this and this. 5 terms on that side. So let's put them in the order I like. So I got an x squared plus a 6x, and I have a y squared minus a 2y, and I still have that 9 over there. Okay. Now this looks a lot like what we had in class. And there's enough information, I can make my squares. So here's my x values, and if I made a square, x times x is x squared, I'd need a 3x and a 3x would combine to give me the 6x. So to complete my square, I would need the number 9. Okay. So if I rewrote what this picture is representing here is x squared plus 6x plus 9. But the number 9 I just put there. Now for some people they're like, no you didn't, it was right there. But most people like to put it there so that they're using the same method in all the questions. So there's more than one, newsflash, there's more than one way to solve this, but this would be one way. Okay, so that's the stuff I need for the x, and there's another way to write this equation that also explains this picture, x plus 3 and x plus 3, and that's a squared. X plus 3 squared is another way to use algebra to describe my picture. Now using the y values, okay, so I have y squared minus 2y, and if I made a square, half of 2y would be a negative 1y, negative 1y. This would make my y square. And negative 1 times negative 1 is 1. So to complete the square, I need the number positive 1. Definitely that's not there. So I'm going to rewrite this positive 1. Now another way to describe this picture would be y minus 1 times y minus 1, which is y minus 1 squared. We added the 1 though to get that. It wasn't there to begin with. And we also have this number 9 here. So if we added the 9, we have to add the 9 on that side. And if we add a 1, we have to add a 1 on that side. Okay, so let's see what we have here still. We still have our 9, and 0 plus 9 plus 1 would be 10. So we're so close. If I subtract 9 on both sides, I get 1. And I have the rest of my equation here, which I'm feeling pretty good about. Hopefully you are too. So the center would be negative 3, positive 1, and my radius squared is 1. So be careful. The number there is the radius squared, just like the number here was the radius squared. So the square root of the radius squared is just the radius, and the square root of 1, ooh, that's kind of cool. The square root of 1 is still the number 1. So I can graph this because I have my center and my radius. My center is negative 3, 1. My radius, 1. Negative 3, 1. Radius, 1. Itsy bitsy tiny circle. Cool, right? Negative 3, 1 is my center, radius of 1. Okay, let's take a look here. I actually like the way this looks, and I actually think I might be able to work it here on this piece of paper, so I'm going to give that a try. My x values are here. So if I made a box, half of negative 8x would be negative 4x, negative 4x. So this would be x times x, and this would be negative 4. All right, that's how I got this negative 8x. So to complete this square, I have to take negative 4 times negative 4, which is positive 16, and that completes the square. So to rewrite this equation, I could write this the x squared minus 8x plus 16. That's the part I added in there. Okay, now let's look at the y information. We have a y squared and a negative 6x. So if I made a picture of that, half of negative 6 is negative 3. So negative 3y plus another negative 3y would combine to give me negative 6y. So to complete this square, negative 3 times negative 3 is positive 9. So the number positive 9 completes the square. So y squared minus the 6y plus a 9 would complete that square. Now, don't forget, we added this 16, we added this 9, we also had this plus 16 here, and all of that stuff has to equal 0. In addition to that, we added this 16 and we added a 9. So we got to add a 16 to this side and add a 9. And that's our big, ugly equation. Yuck. But all is not lost, because we have another way of writing this blue that describes this blue picture. We can describe this picture as x minus 4 times x minus 4, or x minus 4 squared. We can describe this picture as not only this expression, because it's y squared minus a 6y plus 9, we can also say that it's y minus 3 times y minus 3, which is y minus 3 squared. And then 16 and 9 would make 25. Does that make sense? Okay, yeah. So I'm really close. I think if I get this 16 over here, so 25 minus 16 is 9, and we have all the rest of our equation the way we want so that we know where the center and the radius is. So let's do it. My center would be at positive 4, positive 3, and my radius squared is 9. So that would mean my radius has to be the square root of 9, which is 3. So using my information here, I graph the picture for 3, radius 3. Awesome. Now it says, using this information, write an equation. Cool. So we know a generic equation is the stuff in the x squared. So if the x value was positive 13 in the center, we'd have x minus 13. Because remember, if that was a negative 13, that'd be positive. And then the y value, the same thing flipped. If that's negative, this would have to be positive. And what goes here is my radius squared. So that'd be 4 squared. So this would be a possible correct answer. Check out the next video for the rest of the worksheet.